We're going to look at solving systems of linear equations, which we did in college algebra. You solved systems of two equations and two unknowns. And what you found there was that the two linear equations each represented a line in the plane, and the lines might intersect in exactly one point, in which case this x value of 0 plugged in here and this y value of -2 plugged in here satisfies both equations, and it's the only point in the plane that does. If they don't intersect in a single point, they might be parallel lines and have no solution, they never intersect. Or they might actually be lines that lie on top of each other, in which case they have infinitely many solutions. When they have infinitely many solutions, we write one variable in terms of the other. So like I can add y to the other side and get x equals -3 plus y. And then my solution would be x would be -3 plus y, and y can be anything. And that would be my infinitely many solutions that describe this line. When I'm dealing with a system of three equations and three unknowns, three equations form a plane in three space. A plane can also intersect in a single point. Three planes can intersect in a single point, in which case the solution is the ordered triple xyz that satisfies all three planes at the same time. Plug into all three equations at x, y, and z, and they equal the same value. Or we may have infinitely many solutions when the planes line up in an infinite line, or if all of the planes lie on top of each other. And then, of course, we may have no solution if we have parallel planes, and that diagram might look something like that. The planes never meet because they're parallel in space. Okay, let's solve this system. So we can solve this system through elimination or substitution, the same way that we did in college algebra with two equations and two unknowns. In this case, I'm going to add together the first two equations and eliminate the y. So 2x plus y plus z equals 9, and -x minus y plus z equals 1. Add them together. 2 minus 1 is 1x. The y's knock out, plus 2z equals 10. And now let's add the top equation and the bottom equation to also eliminate the y. Notice I'm eliminating the y in both, so that I get down to a system of two equations and two unknowns. So 2 plus 3 is 5x, the y's drop out, plus 2z equals 18. So now once I have two equations and two unknowns, I can solve this system of these two equations either by elimination or substitution. It doesn't matter which. So in this case, I'll do substitution because I can solve x equals 10 minus 2z. Now we're going to plug that in as the x here. I solved this equation. Now we're going to plug it in as the x in the other equation. 5 times 10 minus 2z plus 2z equals 18. Distribute 5, 50, minus 10z plus 2z equals 18. So gather like terms here. 50 minus 8z equals 18. I'm going to subtract the 50 to the other side. -8z equals -32. Divide by -8. And I get z is equal to 4. Once I know z is equal to 4, plug in here to get my x. X would then be 10 minus 8, so 2. Now plug into any equation here to get the y. I'll plug into the top. 2 times 2 plus y plus the z, which is 4, equals 9. 4 plus 4 is 8, so the y is 1. So the ordered triple where x is 2, y is 1, and z is 4 solves all three equations. If I plug it in to each one and check to make sure it works, I should end up with true equations for each one. All right, now let's solve this system. So again, I can do substitution or elimination. I'll multiply the top equation through by 2 and add it to the bottom to eliminate the y's. So if I'm multiplying this top equation by 2, I'd have 2x minus 2y minus 2z equals 12. Add it to the bottom. X plus 2y plus 2z equals 3. 3x, those drop out, equals 15. X is a 5, right, if we divide by 3. Well, once I know x is 5, I can plug back into these equations and simplify them. So I would have 5 minus y minus z equals 6. 5 plus 2y plus 2z equals 3. 10, 5 times 2, plus y plus z equals 9. Okay, let's subtract the 5's to the other side. So I'd have negative y minus z equals 1 when I subtract 5. Subtracting 5 here, I'd have 2y plus 2z equals negative 2. And then subtracting the 10, I'd have y plus z equals negative 1. All right, now notice if I multiply this through by negative 1, I would have y plus z equals negative 1. Same equation is down here. If I divide this by 2, I'd have y plus z equals negative 1. Same equation is down here. This one has infinitely many solutions because I end up with just a statement between the two variables. So I can say y would be equal to negative z minus 1. So then the ordered triple where x is 5, y is negative z minus 1, and z can be anything, solves all 3 equations. There are infinitely many solutions. This is the formula to find them. All right, let's solve this one. So I have, I can eliminate this y here by multiplying this top equation through by a negative 3. So negative 3 times 3 is negative 9x. Negative 3 times 2 is a positive 6y. Negative 3 times 8 is a positive 24z equals negative 3 times 1 is negative 3. So we're going to add to the second equation. 9x minus 6y minus 24z equals negative 2. Okay, so the 9 and the 9 drop out. The 6 and the 6 drop out. The 24 and the 24 drop out. There's nothing left on that side. But negative 3 and negative 2 equals a negative 5. This is an untrue statement. Whenever I end up with an untrue statement, I know it has no solution. Okay? We end up with no solution whenever we end up with an untrue statement. If I end up with a true statement, that's my infinitely many. For example, if I had added this first equation to this third equation, I would have gotten negative y minus z equals 1 and y plus z equals negative 1. Add them together, 0 equals 0. That's a true statement. That's the infinitely many. A false statement is no solution. All right, a student won $100,000 in the Louisiana State Lottery, invested part of the money in real estate with an annual return of 5%, and another part of the money in a money market account at 0.5% interest. He invested the rest, which amounted to $20,000 less than the sum of the other two parts, in CDs that pay 1.75. I will fix that pay. All right, if the total annual interest on the money was $3,250, how much was invested at each rate? Okay, so first of all, I have 3 different rates here. So I'm going to use 3 variables. If I'm using 3 variables, I need to define what they do. So this is going to be the money at 5%, the money at 0.5%, and then the money at 1.75. I know that they total $100,000. So all the amounts put together have to equal the amount that he won. I also know that the amount he invested here, Z, is $20,000 less than the sum of the other two. So X plus Y minus 20,000. Now the last thing I know is the interest that he earned. The interest rate times the amount invested gives me the interest. So to find the amount of interest earned at 5%, I would multiply 5% as a decimal, 0.05, times x. The amount of interest earned at the 0.5% would be 0.005 y, and then 0.0175 z, and that's my total interest of $32.50. So we end up with these three equations and the three unknowns. All right, now we can solve. Let's add the first two equations together. We'll eliminate the z. So if I have x plus y plus z is 100,000, and x plus y minus z is 20,000, adding together we get 2x plus 2y equals, I'm adding, so I get 120,000. Notice I can divide everything by 2 and equivalently have x plus y equals 60,000. Okay, since I eliminated the z, I also want to eliminate the z using the third equation. So I'll use this equation, but I got to multiply through by 0.0175. So 0.0175x plus 0.0175y minus 0.0175c equals, okay, I got to do 20,000 times 20,000 times 0.0175, and we get 350. All right. Now I'm adding to that the bottom equation, 0.05x plus 0.005y plus 0.0175c equals 3250. Let's add them. All right, so I'm going 0.0175 plus 0.05, and that's going to be 0.0675x, and then I'm adding 0.0175 plus 0.005, and that's 0.0225y, and then the z's knock out, and I have 3250 plus 350, and that's 3600. Okay, now I can either continue to do elimination or I can do substitution. Just say y is 60,000 minus x. So I'd have 0.0675x plus, I'm substituting this in this equation for the y. 0.0225, y is 60,000 minus x equals 3,600. So 0.0675x plus 0.0225 times 60,000 is 1,350 minus 0.0225x equals 3,600. All right, now I'm combining these like terms, so 0.0675 minus 0.0225 is 0.045x, and then I can subtract 1350 over to the other side, so 3,600 minus 1350 gives me 2250. So now I'm going to divide by 0.045, and I get x is 50,000. As soon as I know x is 50,000, I plug in here and get y is 10,000. Plug in anywhere to get the z, so the easiest equation is the first one. So 50,000 plus 10,000 is 60,000, so this has to be 40,000. So now we would answer the question by saying he invested 50,000 in real estate, 10,000 in money markets, and 40,000 in certificates of deposit. All right, a sparkling water distributor wants to make up 300 gallons of sparkling water to sell for $6 per gallon. She wishes to mix 3 grades of water, selling for $9, $3, and $4.50. All right, so the cheap one is the $3, the middle is $4.50, and the expensive one is the $9. My mixture needs to sell for $6. All right, I need to use twice as much as the $4.50 water as I do the $3 water, but otherwise I don't know. So I'll just call this X, this is Y, this is Z. So my total gallons in the mixture should be the sum of those. So I'm going to have 3 times X as the total cost for this water, 4.5 times Y as the total cost for this water, 9Z here, and then I know that the total cost that I want has to equal 300 gallons, so I'm going to have 6 times 300 as my total cost here. So this is one equation. Adding these up to equal this is a second equation. And then my third equation comes from the fact that I've got to use twice as much of the 450 water, well that's Y, as the $3 water. $3 water is X. Well, if I'm using twice as much of that, I got to 2 times it, right? So my 3 equations will be y minus 2z equals 0, x plus y plus c. I think I put the wrong variable on something here. Expensive water was z. I wrote it backwards on the when I made this up, sorry. So my z was the cheap water. So I did x plus y plus z equals 300. That's the total volume of water. Then the amounts, 9x plus 4.5y plus 3z equals 1800. And then y minus 2z equals 0. So this gives me easily y equals 2z. I can plug that into the other 2 equations. So I would have x plus 2z plus z equals 300 and 9x plus 4.5 times 2z plus 3z equals 1800. Rewriting those, we have x plus 3z equals 300 and 9x plus 9z plus 3 more z, so plus 12z equals 1800. So if I multiply this by negative 9 and add them together, I'm going to have 0x, negative 27 plus 12 is negative 15z equals negative 2700, that's negative 900. So if I divide, I get z is 900 would be 300, so 60, I believe. Once I know that z is 60, I can go here to get y. Y is 120. And then I can go anywhere, so I'll go to the top equation to get the x. X would be, well, this is 120 plus 60, so 180, so I need another 120 to make it to 300.